Welcome back to the Rollup. VMs, and more virtual machines. If you've been following us for the modular thesis, you know that we are pretty excited about what's going on at the virtual machine and the execution layer. Today's conversation with Robert from MultiversX was strictly about execution layers. We talk about the pros and cons of many designs in the space today. We talk about parallelization, and we talk about the feature of the modular stack with regards to execution and why it's so important that we scale execution. This is going to be a good one. You guys will enjoy. Thank you for being here. Let's jump right in after a word from our lovely sponsors.
Fuel achieves higher throughput by utilizing a novel UTXO-based approach that allows for parallelized execution. This design significantly accelerates transaction processing, which enables Fuel to handle vastly more transactions than non-parallelized systems. Thanks to advancements introduced by Fuel, Ethereum rollups are set to be more powerful than ever before. And Fuel is not just enhancing Ethereum rollups, it's redefining them, making them faster, more scalable, and more adaptable to meet the needs of modern applications and developers. Go to fuel.network, that's fuel.network, to learn how to build on the Rollup OS.
Welcome back to the Rollup. Today, a conversation on something that we are particularly bullish for in the modular thesis for the coming months is this idea of execution environments, and particularly optimized execution environments for better user experience. We think that there's been a lot of talk around data availability for the last 3 months, rightfully so, after Celestia's launch, Avail, EigenDA, and others. But we actually think that the more impactful changes to rollups and to general execution environments is going to happen at the execution layer. So we're here today with Robert, who's a core engineer for project MultiversX, which has a super interesting VM design, which we will touch on for sure. And of course, with Rob. Welcome in, Robert, and it's good to have you on.
Hello, thanks for having me. I'm quite happy to see all those changes in the crypto space finally happening. Finally, people figuring out that, there is an other alternative way of execution, which can really scale and actually can make some better user experience, better help on safety and security for both users and developers. So it's quite actually a relief that things are moving forward and not everybody building on the same stuff, which is actually not necessarily good for our complex life.
Yeah, I think so. Do you agree with our sentiment? Like, do you think that data availability is an unlock, but the scaling at the execution layer in innovative ways is much bigger of an unlock? Or are they equal? Or kind of like, how do you view the comparison in terms of solving scalability bottlenecks from like data availability versus execution environment scaling?
Both of them are necessary because you cannot work if data availability doesn't exist or it's not handled well, then you cannot scale because you cannot actually offer those kind of security primitives for the users. But execution, it's where things are happening for front facing for the user. And then you had to make some changes and add the execution level in order to actually make awesome applications. Like, let's be real, all the applications which are Web 2 based, the new ones, the AAA games or AAA applications, whatever, they are amazing to use, easy, seamless interactions, seamless onboarding, everything is like fit for the user. We are still really far away from that experience in terms of crypto space, and some of those things which is happening in Web 2 for the apps couldn't be handled using legacy technology, and that's a fact. There's no denial on it.
So is that? Oh, please finish.
And so you need, in order to reach billions of users, you actually need those kind of better front-facing, user-focused products which resolve problems, and that can be done only with, from my perspective, on new VMs, which offer a better developer experience and better user experience.
And that's a sentiment that we've heard quite a bit, is that the reason these AAA games and these high-powered applications are not available today is because there's a lack of scale. And so I'm curious, does the lack of scale, we can even look at like what the current landscape is. Ethereum right now has somewhere between like, I don't know, 20 and 30 transactions per second. You see like some of these other rollups that they're getting up to like maybe 1,000 transactions per second, which is quite a bit more. It's almost like 50x times that. Does the limitations of scale happen at the execution layer, or do they happen at some other parts of the stack?
It happens on multiple levels. It's not only like bytecode or contract execution per se, but actually access to data as well and access to complex operations. When we look at Ethereum and how Ethereum was designed, it has only one big Patricia Merkle tree in which you try to execute. And as this tree is growing and growing, getting information and writing information, it's getting slower and slower. But if you can make this kind of trees smaller, for example, one tree for one smart contract, you actually resolve a set of problems. Then you can add caches. Then there are a lot of operations which are, let's say, common goods, like big int mathematics or big float mathematics or cryptographic primitives. Why would those things need to be executed in Solidity or an interpreter? Just tap into existing audited libraries for cryptographic, offer an opcode for the developer, and the developer will use that opcode. And you don't have to reinvent the wheel and reimagine smart contracts and optimize more smart contracts for these kind of things, because you have all those, like, let's say, libraries beta tested by NASA or beta tested by serious applications and serious people.
Yeah. And so we kind of get to the state where I personally think that we share this belief here where we don't really need too many more EVM L2 general purpose rollups. I think that parallelization at its core is like effectively a standard now. And that these kind of, the only way that EVM will scale is through parallelization or effectively kind of being a like counterpart or a part of a system which offers other execution environments. So I generally want to get your take on this. Is the EVM going to be in a state of less usage over the next 10 years? Or do you think it'll continue to develop in terms of the broader expansion of crypto? And then also, how does the impact of these alternative virtual machines and these parallelized execution environments, how do they intersect with EVM to kind of provide both functionalities and kind of plug into different types of applications?
There were a lot of questions here, but let's start with some of the things. I think that EVM and will drop on how many apps there will be developed on EVM, especially when we look at Solana, when we look at Move, Sui, Aptos, and we look at MultiversX. In all those places, you actually can write in Rust or Rust-like environments. And then, these kind of projects are going out to universities. They are keeping hackathons. They are teaching a lot of non-Web3 people to come to Web3 and develop. Those students or non-Web3 people, they don't know Solidity, but they most effectively know Rust or C++, and they will actually start developing on those languages. And then only, let's say, the OG guys remain on Solidity, who were developing on Solidity, and they still remain on Solidity. And then the crypto world will move on towards, like, right now, it seems like Rust-based DLTs or Rust-based languages. You have a lot of functionalities, better IDEs, better unit testing, better audits, more people out there who can actually review your code and see what's good and what's bad about it. And in some sense, while the liquidity is still on Ethereum and still because of this in EVM, people will write and are actually writing interoperability modules in order to understand EVM inside their chain, or at least EVM messages inside their chain, in order to tap into the liquidity. And we cannot deny this fact that everybody wants to tap into the liquidity of Ethereum, or let's say steal liquidity from there in order for their application. But that's like the truth out of there. So there will be different modules in which this kind of messaging protocols, cross-chain protocols will work and evolve. But the more development we see, the more they will go outside of Solidity. That's what I see. And even with the new bridges like Acceler or Layer 0 or Entangle, they are moving to, for example, to using Tendermint SDK and then developing in Go, or using a Cosm Wasm, building in Rust. So these will be the languages to be used further.
Is there a way to compose with the liquidity on Ethereum and also use an alternative VM?
There are some types of doing that. So you can have asynchronous ways in which you passage messages, and then you are actually executing the user-facing app is actually executing on another layer, but you have a set of, let's say, relayers or a service which transfers those kinds of side messages into Ethereum side messages, then you tap into. One of the things we try to do it, for example, with our SpaceVM, is to put our Wasm-based VM and EVM one next to each other and offer atomic composability between these two. This would be a way in which you could, let's say, could launch an Ethereum L2 in which you have both of these things. Then on the Ethereum L2 side, you can tap into, for example, an Optimism or an Arbitrum type of rollup and get all the information from Ethereum as you would look like, but you would, on top of those applications you developed on your EVM, you would tap that directly into a Wasm-based contract, which is user-facing. One of the ideas in this sense is, for example, if you do that and you offer like multi-calls for users, then a user could do approve, execute, revoke approval, or stuff like that inside one execution. All is managed by, let's say, the SpaceVM, but you call the EVM in this side. And then you resolve a set of issues for the user that he has to sign a bunch of transactions, give out a lot of approvals, and just doesn't know what's happening in the back. This way you can keep it, let's say, more safe. Or one more example I would give is that if EVM doesn't want to change it, so okay, you put the SpaceVM next to it. In the SpaceVM, you have like other type of cryptographic proofs, like the SecP 256R1. So you would be able to use that one, and you could create applications without seed phrases because you could use the passkeys from your phone. So what you imagine is that you create an account abstraction, which is controlled via passkeys from the phone. The transaction is pushed by a relayer, for example, with a relayer and a gas service or a subscription service. And then you have a completely great account abstraction layer, which still communicates with EVM underneath. And the user is completely safe. These kinds of, let's say, innovations or moves inside things can happen, and then you are still directly connected to the liquidity and what's happening on the Ethereum layer.
Yeah. I think it's funny. People are like, EVM's dead. And alt VMs are going to win out, and next gen VMs are so much better. And then everyone's like, well, we have to connect back to Ethereum still, guys. It's like, yeah, okay, guys. It's funny stuff there, bud. Stupid question here. I'm not a computer guy, but I've heard Wasm is not meant for blockchains. It's more meant for like browser apps. Why, like, is this true? And like, why are you guys using Wasm, or why is Wasm a good or a bad virtual machine for blockchain?
That might have been true 6 or 7 years ago, but since then there was like an insane evolution of Wasm and an insane evolution of compilers, of compiling Rust or other languages to Wasm. Like 1 month ago, I was in Barcelona at the Wasm summit, and there was like insane things happening there. And the thing is that people are running like complete services on Wasm, serverless services or on-demand servers, which can spin up in milliseconds for you, for your microservices with thousands of machines. And like a bunch of companies like Sony is using it for IoT and for like the whole stack. And Wasm actually was developed by Mozilla, then Google, Facebook came into it. A lot of people put a lot of effort. Then LLVM, the compiler, was actually updated several times. And it has, for example, if you look at Python is used to test out smart contracts, or Python is used to do all kinds of interactions. If you take the Python code, compile it in Wasm, and you run it the Wasm for the same interactions, it's 3 times faster. And you can do so much more amazing things. And Wasm, it's really deterministic, executes fast. You can do it with compilation, or you can do it with interpretation. With compilation, it's even faster. You can do some amazing things, like you compile once, then you keep the serialized object. It's called ahead of time compilation. And next time you don't compile, only deserialize. Or another way of doing is that you compile and you keep the compiled object, and next time you simply just run it. And with our benchmarks, you can get 1.3 times slower than running on the same code directly on barebone machines. So that's kind of speed you can reach. And with Wasm, what you can do, it's actually make not even smart contracts, but if you go above in the stack, you can make microservices and front end safer. What you could do actually is to run the microservice and to run the front end as a Wasm bytecode directly on the user's phone. It runs in a sandbox. You can put the binary for the front end directly on blockchain for the phone to read from there, to have the authentication from there. For example, and as an inscription, you inscribe your front end to the blockchain, you run it, the user have the complete security that he is running the software which is supposed to run. There is like the front end was not taken over. It's just one verification. And that actually everything is run faster. This is one of the things we want to go for, and to generate all these steps from smart contracts, microservices, and front ends from Rust or TypeScript, JavaScript, and to have the whole stack for the user.
Cartesi is your home for app-specific rollups. At the forefront of developing new tools and platforms that enhance the capabilities of blockchain technology, Cartesi enables applications that are flexible and built to scale. Build on a full Linux environment and use traditional software libraries, but in blockchain development. Go to cartesi.io, that's cartesi.io, to learn more about building your own app chain today. Can you give a concrete example of what one of these verifiable microservices could look like?
So a microservice actually reads a bunch of data from the blockchain, then makes some computation, and forwards it to the front end in order to have it for the user, or like specifies what kind of transaction the user have to sign. In our example, we write these kind of things in TypeScript. Now you can take the whole TypeScript code, compile it, inscribe it on chain, or put it on directly on the tree. Then next time when the user checks that he wants to interact with app X, then the wallet, or let's say a microservice runner on an app, checks the blockchain, downloads the code, runs it, executes it on the user, and then it directly the user can after that sign the message and do it. And actually, it's much more scalable than running your own microservices. In a lot of times, we had a bunch of issues with our microservices, not the blockchain. The blockchain was running fast, but like having the indexer, the microservice, getting too many API calls. But when you have these things running on the user facing, it runs on his own machine. Or what you can do more with it, you can actually run transaction simulation on the user's machine. So the user would see the result before signing it, but directly, like, you cannot fake it.
Yeah, I think it brings back like Satoshi vibes, because like he was all about verify, don't trust. To run something on a local machine is much more decentralized, much more self-oriented than something that's running on like kind of a cloud network or a centralized server. And so I think the infrastructure makes a lot of sense to distribute this infrastructure across this network of local machines. Could you give some examples of like what microservices are unlocked via this new infrastructure?
We don't have this live because, we went to the Wasm weekend in Barcelona, and then we saw a lot of people using this. But we saw that there are actually some banks using this kind of Wasm stuff in order to run multi-party computation before everybody is running the same microservice, signing them, then aggregating the signature and putting the data out between some banks, and to create trust in this. There was some keychain application there in this sense. We actually saw a lot of games running like this and actually accessing via the backend data. And, the Wasm, it's like you can run it on any browser and it runs deterministically. Plus it's like it's verifiable. You deploy that or you post that Wasm code and you know what's happening there. It's somewhat readable as well. You actually can decompose it and put it in another language and like put like verified tags on that everything is fine. And spinning up Wasm, it's milliseconds. So the user doesn't see it. It's not like you have to spin up the whole complete system.
Gotcha. And I think that's like the Wasm is the microservices are chains. So each individual app chain could be like its own microservice. I've even seen like rollups are the new microservices or vice versa, which for some reason that word has a bad context, but not exactly sure why. Out of Wasm VM, you're clearly bullish Wasm VM. What about MoveVM? Is MoveVM exciting to you?
Move brought a lot of innovation in terms of security inside the space. Like linear storages are one of the great things, like actually needing, because I think people from Facebook back then with DM, they saw that, okay, there have been a bunch of reentrancy attacks. Why don't we stop it like at the basis? Sometimes when you stop some of these attacks at the most basic fundamental level, that's the most scalable, or you resolve some of these issues. And then, yeah, it's pretty easy to write code, and it's like having those kind of primitives built in to the whole tooling system. It makes people more confident. And one other thing, it's like all the audits are cheaper. like auditing is Solidity costs 1, and then auditing in Wasm or auditing in our SpaceVM, it costs like 5 times less at least, or stuff like that for the same code, because they don't have to verify all those attack vectors they have in Solidity. That's one of the funny things. And yeah, these kind of things are needed. And when we see outside of crypto space, we see that a bunch of companies which are working with highly secure models or environments where you need high security code, they add everything inside: formal verification, chaos testing, and a lot of things. Some of those things we want to introduce direct. Our VM is actually formally verified. Then on top of that, your smart contract can be formally verified. There is a tool we are working on into releasing towards the builders. And then, for example, auditing companies can actually use that as well in order to write their own specifications and verify that the contract is actually to that specifications. There are like some languages are a little bit exotic, but for auditing companies, it makes sense. It's about a lot of mathematics. And when you have like formally verified contracts and formally verified VM, you can have like proof generations, mathematical proof generations easier as well, in order to demonstrate the correctness of whatever is happening back then. It is quite nice to see that people like Move took this approach as well. We did this as well on our SpaceVM and especially on our assets. Our assets on SpaceVM or MultiversX are native. Every asset is native, like from fungible, non-fungible, semi-fungible, financial tokens. Then all the operations are at protocol level or VM level. So there is no reentrancy, and there is you cannot actually lose some of those tokens pretty easily. And when you have these kinds of primitives built into deeply on the layer, even composability, it's easier. One of the things it's like when you have like native assets is that you can add multiple opcodes into the VM in order to enhance composability for the developers. One such example is, for example, in our case is back transfers. And then you can have integrating any DeFi app with only one line of code. And any DeFi smart contract you define as an interface, you call that interface, and then you have all the transfers that smart contract send to you as an object, and all the output as an object, which is actually type safely verified. If any verification fails, or the transaction fails, so you are safe, then you just iterate on the transfers, verify whatever that DeFi app sent you. Is that okay? If I'm okay with all the assets I was received, then okay. Otherwise, I can fail the transaction. Nothing happened, everything is reverted, and then I can move on. So we see like derivative contracts building on top of liquidity pools or routers with one line of code. Or like NFT marketplace buying. You can buy NFTs with any token which is listed in any kind on that NFT. Then it's like he has one line of code to integrate a router which does a bunch of stuff in the behind, and it just works.
Yeah, that's awesome. I think those types of improvements have broader implications for developers, users, of course, and just the expansion of a given network. So you're bullish on the properties of MoveVM, especially regarding the security properties, which things like formal verification and real-time smart contract auditing. What about the idea of UTXOs versus the account-based model? What are your thoughts on VMs which use UTXOs instead of the account-based model?
I didn't really necessarily get into details of UTXO-based VMs. I see that there is some great security implications there, because as a user, I can just send a few UTXOs combined together, and I make an execution on that UTXO, not on my whole account, which, for example, compared to EVM, it makes a lot of sense because you can lose a lot of money through hacks, and it is pretty easy to fall into scams. But I think it's pretty hard to develop for developers and to switch into a mindset of UTXO development. And I think that if you have native assets at the protocol level, you can reach the same conclusion. For example, in our case, you can have multi-transfer of multiple assets and execution towards a smart contract. And then the smart contract doesn't have any access to any other assets from you, only what you signed. And what you said that, okay, I want to send one ETH, $100 and one Bitcoin to do, I don't know, to do a derivative. And then he can only operate on those kind of assets and those kind of transfers. So that's how we resolved it.
And it's like easier to like kind of go back and backtrack as to where things came from, less so than in the account-based model, which I think is interesting. Cool. All right. What about the SVM, the Solana virtual machine? Are you bullish on the Solana virtual machine, or have you looked too much into it?
I looked a little bit to see how their tests and how Rust is used there. There are some good properties. So hardware acceleration and executing some of those things through hardware makes a lot of sense. From my perspective, it was launched too fast, and there are still a lot of things which should be resolved and can be improved. They have copied some of the things from EVM, and that's why users can be drained on Solana because of this. They somewhat copied the ERC20 token standards. They made their own factory contracts through which you can launch your own version, but still they didn't have resolved the issues regarding reentrancy or the issues regarding user facing when your wallet gets drained. These kind of things, let's say, should be enhanced. Hopefully they will do it, because there is a lot of movement around Solana VM. But they did a pretty awesome job about parallelization. It seems that they nailed it, because people can actually write contracts executing in parallel with pretty much ease. And then they opened up let's say that everybody is putting parallel execution. This is fine. And again, using Rust is really fine. I see a lot of improvements to be done there. It's their job to do it and to make the place safe. And I think that Solana has actually made a case for scaling scalable chains. That's the first time, everybody is using Solana, and it's not like the legacy chains, but something which is really scaling, and it's a good thing, because it opens up for more innovation and more development in the broader crypto space.
And the BitVM, what do you think about the Bitcoin VM? Navigating multiple blockchains can be complex and cumbersome. Let's say you want to deposit into a lending market on Polygon because they have the best rates, but you only have funds on Optimism. So you bridge your funds to Polygon only to realize that you need Matic to pay for gas. Maybe use a centralized exchange, or you ask your friends to pay for the gas, but only then can you finish your transaction. In a chain abstracted future powered by Connext, this is not the situation. You can connect your wallet to any dApp from any chain with all the complexities of swapping, bridging, and depositing, all completely abstracted behind the scenes. Head over to connext.network, that's connext.network, to learn more about Connext Chain Abstraction Toolkit.
Come on, that's like, I don't want to necessarily say, but that's like bullshit. Like, really, come on, you cannot develop anything there. Like, let's be serious. That's not a Turing complete stuff. Whatever you build there, it's like 100 or 1,000 times worse than you would build on Ethereum, or 10,000 times worse than you would build on Solana or Move or SpaceVM.
Why?
That's a fact.
Why is that?
Because there are no opcodes. There is no support for almost anything. You have to make a lot of mathematical assumptions and a lot of operations for nothing. Everything will cost huge amount of tokens and actually huge amount of money to do that. And there is not like execution, that's not like somebody will say that, okay, this execution is correct or not. And it's no composability. There are a lot of things adding one to the other. Yeah, it's a narrative on the Bitcoin
so
side.
You're not a big Bitcoin scaling rollups believer, are you?
I don't see a very good way to do it right now on Bitcoin. If they change some things, yeah, it might happen. But I want to see scaling or scaling or L2s like to be real, like no centralized sequencers. Let's have everybody to be able to run their own nodes, to do stuff, to verify stuff. I don't want to get into a place where there are a lot of custodians and I am sending wrapped Bitcoin instead of Bitcoin because I am using custodians, which are, let's say, JP Morgan is the custodian for that, and then I can send sats for nothing because they are running the server. Come on, that's so far from the cyberpunk vision of crypto and the space. Let's be real. The thing is that when you have multiple nodes, hundreds, thousands of nodes running your system, you have censorship resistance. You have a network which can actually, even if countries are attacking that system, it still works. It still works 24/7. But when you have a centralized sequencer or where you have like 3-5 addresses which can do, a state actor can simply destroy that and the protocol stops. All your transactions are censored, and then you can do KYC and EMS.
I recently read that Ethereum's two biggest problems are token issuance, which was some problem that I read about, but it was a little bit tough to understand with regards to the inflation and deflationary mechanisms of EIP 5059. But that the other one was lack of censorship resistance. Do you think that Ethereum switching from proof of work to proof of stake was a mistake?
I don't think so. So proof of stake is great, but proof of stake when you have a bunch of nodes and you have decentralization, and we see that Ethereum has a lot of actors there. Everybody is putting their stake and everybody is running their set of validators. So if my transaction is not put by Coinbase because I would need KYC for that, then somebody else will take it up and will put my transaction. So I have censorship resistance. That's fine. What's not fine when you have like 5-10 nodes running in a system, and then those entities who can run those 5-10 nodes, they can be stopped. When you have thousands, you cannot stop. That's the beauty of the chain or blockchain and these kinds of the vision of Satoshi, that blockchain could never be stopped.
Yeah, I want to come back to the Bitcoin thing because I feel like this is going against the status quo a bit at the moment, and so there is like this idea of kind of like expanding the functionality of Bitcoin. And what I gathered was that the main limitation of the Bitcoin network right now is the lack of opcodes. And so there's this thing that's been floating around. It's called opcat. It just got assigned like a Bitcoin improvement protocol, like a BIP 420. Are you familiar at all with opcat? Like what is the purpose of that opcode, and why is this such a unique thing when it comes to Bitcoin that doesn't traditionally have opcodes?
Actually, opcat is you can move two types of vectors together. That's what I got into what basically means. And actually today I was reading the BIP 420 in this sense, and I heard in ETH Denver about some people speaking about Bitcoin L2 and a Starknet event. And it was funny of how they explained some of the how you cannot do a multiplication using the opcodes, but you can do multiple multiple adds or some other types of mathematics in order to resolve some of your problems. I think that it's a start, but it's just that's not enough. That's quietly not enough. How you will do the cryptographic proofs, how you will do account abstractions with passkeys, for example. There are a lot of things which the users, from the user side, it will be not good. And then, as it's not gas, but you have to pay for every bit of takes data you add into Bitcoin, it will cost a lot, like a lot. Yeah, miners will be happy about it, but that's not a scalable way of running.
Yeah, this is fascinating, and I just have one last question on this, which is that you mentioned that it's not Satoshi's vision to have just a set of nodes like 5 or 6 that can be censored, and right now Bitcoin has like this very vast set of nodes and miners. I'm not sure exactly about the centralization of the miners, but are you suggesting that taking like Opcat, doing these Bitcoin L2s and BitVM reduces the set of nodes so that it goes from however many, let's say there's 1,000 full nodes on Bitcoin's network right now, and are you saying that on BitVM it constricts this set of nodes to a smaller set?
No, I'm not saying that. I'm saying that Bitcoin L2s, as they were envisioned by some of the teams, will be run on centralized sequencers. They will be run like you will give some kind of custody for your Bitcoin. Not necessarily custody, but you will send to an address which maybe have a multi-party computation for that UTXO to move outside. Then you will actually not interact with the Bitcoin network. You will interact with an L2, which is controlled by, I don't know, that multi-party computation, which is fairly limited. Then if somebody attacks that multi-party computation, which is like 5 or 10 nodes or 1 node, then everything is gone. You may have an exit tree, but I don't know how they will build it. For example, on L2s on Ethereum, you have the exit trees, meaning that even if I have my tokens in an L2 and the L2 stops for whatever reason, for example, a network state attack, I can go on and get my funds back. I don't know if that will be possible with Bitcoin L2s with this kind of opcodes. And this, the opcat, it's like only the concatenation of two values, nothing else. It's like...
Right, it's not multiplication. It's not like any of the more advanced types of computation. Okay, so do you think is it ever possible to achieve the state of like what we have on Ethereum as rollups right now? Like everything on Bitcoin you're mentioning is more like a side chain. It has its own security principles and trust assumptions. Do you think there's a way that we could scale Bitcoin to where we don't have any lack of the security principles that are inherent to the L1, but we can still get some greater throughput and scale?
Yeah, definitely. If they put SpaceVM or other VM especially for rollups to run, like to have actual codes for that and actual verification.
SVM on Bitcoin coming soon.
But like directly at the miners, at the layer 1,
they're not going to enshrine.
This guy's just clowning us now.
That's silly.
If you want to do something right, you have to do that. Otherwise, it's like, I don't know. Otherwise, it's like...
But even if there's BitVM, right? Like it's still... and there's still like... there's still trust assumptions that are baked in, and you're trusting a different set of... You're not trusting the miners. You're trusting the validators of this L2.
Yeah, actually, yeah. So you are... Whatever you write, it's on the L2. It's like hardly... It is hardly getting the security primitives of Bitcoin.
Yeah.
It's run by others.
Just one last question, man. How did you come up with the name SpaceVM?
MultiversX, it's like multiverse at the power of X. So we have a lot of space regarding or names in our vision, like X Portal, X Fabric, stuff like that. So using And at the basis of everything, like let's say in terms of physics, it's space. So all the running is done on space, so SpaceVM, and like the smart contract framework we are using, which is a DLT on top of Rust, in which you can do integration, unit tests, interactors, and formal verification is coming as well. That's named Spacecraft SDK. As you are building your spacecraft to move towards space with your smart contract. And actually spacecraft comes from SC as well. So it has the
big astronaut
same kind
energy.
of
Thank you, Robert, for coming on and sharing some insights, man. Really appreciate you and your execution layer expertise.
Thanks for having me. It was a good chat.